southernmost site of this cruise. And what shall I do to make, okay. Is that better? Let's see. Okay, is that better? Great. All right, so, oh, sounds pretty loud to me. We're at 40 Mile Bank. We are continuing our search for mineral-rich hard grounds, phosphorites and ferromanganese crusts, and at this site it's likely to be phosphorites. We're trying to understand the animal and microbial communities associated with these specific minerals, motivated in part because Southern California deep fauna is not all that well explored, but also because these minerals are being targeted by society as a source of metals for a whole host of electronics and industrial processes and green energy and so on. We, on this particular dive, we're also deploying a series of colonization experiments in which we're putting out different kinds of substrates for invertebrates and microbes to colonize. We'll be putting out a series of bones. You can see them on the front porch there. These are Greg Rouse's bone experiments, and I believe there's cow and pig and maybe some chicken bones in there. They are mimicking organic falls, like whale falls, and there are bone-eating worms, a whole slew of species of ossidacs, which are bone eaters, that Greg is hoping will colonize these. But we're also putting out pieces of wood, carbonate rock, some ferromanganese rock, and some phosphorite rock to look at whether different organisms have, or different species have settlement preferences, and we hope to collect these next September on the Falcor. Our experiments will go out somewhere around 1,100 meters and 700 meters. This parallels a set we deployed on San Juan Seamount at the same depths, but much further offshore, and we're thinking the colonizers would be different inshore versus offshore, and at higher oxygen levels, which we would find at 1,100 meters, than in the core of the oxygen minimum zone at 700 meters. Okay, Kira, do you want to add anything about the minerals we're going to explore?
Sure, thanks, Lisa. Yeah, we're in the geologic area called the Southern California borderland all throughout this cruise. And yeah, as I've been saying every day, but today I'm going to get it totally right. This area is geologically interesting. It has a lot of rugged topography, and that's in part because it's got a lot of different plate boundaries. My favorite factoid is that it's the site where there's been a triple junction of 3 different plates, the North American plate and the Pacific plate, and then a small little plate called the Cocos plate. They all 3 collided in a single point that we call the triple junction. And that has created a lot of really interesting bank features, and the continental crust extends pretty far out. And so that's why we have all this interesting topography. And in ancient times in the ocean during the Miocene, we had a lot of carbonate sediments that were turned into phosphorites. And those are some of the substrates we're looking at here. Yeah, I do want to note that this particular region there's no current mining interest in this particular region, but the mineral type has been considered for extraction in other parts of the world. So it's definitely important and interesting to look at the distribution of those minerals in this region, and we'll look at their mineralogy and chemistry and then compare it with all of the biology at different size scales that are living in and on these and providing ecosystem services. So we hope to find a lot of phosphorates today at 40 Mile Bank, about 40 miles exactly offshore, and we're glad to be out here exploring on such a fun Tuesday that has no other important significance.
Nothing else going on out there.
Nope. Not that I know of, not down here.
No, ma'am. Just finalizing some targets for the pilot software, and then we can take a look at the dive.
Can you remind me, Erin, what water ranges we're going to be looking at today? Or Lisa?
Sure. The depths.
Yeah, the water depths ranges.
Well, our target launch depth is at 1,114 meters.
Okay.
And this last waypoint, I believe, is around 600. But
Yep.
Let's take a look.
Okay, so a little bit deeper than we've been diving the past couple of days. Hopefully we'll see some interesting new biota.
The last target's just a little bit shallower than 600.
Okay.
This is sort of a dive from just below the oxygen minimum zone or the lower boundary into the core
Oh,
of the
nice.
oxygen minimum zone. But our depths have been selected to match the experiments deployed on San Juan Seamount.
Nice. That's going to be a really good comparison.
We have a comment from this science chat that one economic mineral mined in the Southern California borderland on Catalina Island has been silver, which is common in hydrothermal and other seeps in the borderland banks and ridges. I did not know there was silver here.
Yeah, that's interesting. Thanks for that input.
That's Mark Legg telling us that. Thank you.
Yeah, that would be still, I think, considered terrestrial mining, technically not offshore mining, but certainly interesting. It's a very diverse region geologically and mineralogically, and certainly host many different kinds of mineral and metal enrichment in those many rock types.
Many animal types.
Absolutely.
One thing we found that is every dive has been different assemblages, some of the same animals, but often in different abundances.
Yeah.
There's a comment that there's also arsenic and mercury around here. In the rocks, I think.
Yeah. Yeah, that's true. He cited Jim Hine from USGS, which was my mentor in the marine minerals program. There was a mercury and silver arsenic rich crust deposit paper that he put together from the California borderland. So The crusts themselves are soaking up lots of interesting minerals associated with all of the organic matter decomposition in this region.
All right. Do you guys have high pack visible back there?
Yes.
Yes.
All right. So we're zoomed out to the kind of full dive track. The ship is on the left to the west, and then we're progressing up the slope. So right now we have the bathy color map on. Red is shallow and greens and blues are deep. The black lines are 10-meter contours. We're starting at AG, which is down right here where the ship is. I could zoom in on that in a little bit. And then we're progressing up these slopes. So it's pretty straightforward as far as waypoints. We go AG, AH, AI. But then when we get to AI, there were these kind of ridges or spines that may prove to be interesting if we're having trouble finding what we want. So AI lowercase a and AI lowercase b were some picks on those spines. And I also put in some lines with kind of the orientation of those spines to help guide exploration if we choose to. These were the two that were picked downstairs, and I just added this one as well.
Aaron, which waypoint is 700 meters?
700 meters is AJ, so that's right there if you can see my mouse.
Yeah.
And
So
I'll make sure and note that that's an experiment drop, correct?
that's correct.
So I'll put that note in just in case watch changeover happens and I forget to warn Rennie. All right, and then we finish with AK up there on the top of the ridge. So that's our bathy. We have the slope as well, and the slope color map, again, red is higher slope, blues and greens are low slope, and the range on the slope is 0 to 35 degrees. So get a feel for that. So we're starting pretty flat and going up. And then our backscatter is all kind of just gray pixely, so quite darker down here, which we would think would be more sediment rich, and then maybe a combination of rock and sediment kind of moving up to the top of the terrace.
Cool. Thank you.
You're welcome.
Yeah. So for those watching, we're at just about 450 meters almost, and oxygen saturation is 6%. So it's dropped from over 100% at the surface. We're right now probably hitting what would be considered the boundaries of the oxygen minimum zone, the upper boundary. And it's pretty low, but there are animals that can manage it, survive here. It's about 20 micromolar, which we consider the boundary of the oxygen minimum zone. And it's likely that the entire dive will be within that 20 micromolar boundary, less than 20 micromolar, once we're on the bottom.
And Lisa, to be considered anoxic waters, how low does it need to be? 0.0%?
Yes.
Uh-huh.
Basically, it needs to be below the detection limit.
Below detection.
So it needs to record as 0.
Wow.
So most of the time, the waters are not, and especially in this region. We don't get completely anoxic waters here.
Mm-hmm.
But there are places off Peru and elsewhere that do.
Yeah, we've been close. Yesterday we've been below 1% oxygen saturation.
Well, but 1% is still a few micromolar.
Uh-huh.
So depending on the sensitivity of the sensor, You really need to be in fractions of a micromolar to be below detection limit.
Okay. Very interesting.
2 micromolar of oxygen isn't very much, but as you saw, it's enough for a lot of different species because we saw a lot of kinds of animals.
I just picked up my phone when you said that. Let me make sure we can get connected. Oh, push, please. This thing's been very finicky. Not yet. Oh, yeah, you have to hold it so it flashes blue.
Going to give a shout out hello to my son, Garen Checkley, who told me he's listening to us today. Hi, Garen.
Hello.
Hello, hello.
Hello.
Greetings, Earthling.
My Mrs. Doubtfire impression. Hello.
Could you give me another push, please, if you get a chance?
Yeah, sure.
Connected. Thank you. You pushed it twice. No, I was looking at my phone. I might have missed a few.
So we're not sure, but this may be the first time that 3 out of the 4 in the front row have been female.
Oh, yeah.
Maybe a nautilus first.
Wow. That's awesome.
Yeah.
Is that a first for you guys?
I can't think when else it would have happened because Jess has just come up as our first female Herc pilot. Is that true?
Yeah.
So
Is this your first Herc piloting cruise?
Officially, yeah.
Great. Well, the women in the control room definitely outnumber the men this morning. There's
indeed.
5 women and 3 men.
Yeah.
A while back, I saw a very cool picture of a B-52 bomber crew. They were all women.
What did you say about a bomber crew?
A B-52, the B-52 bomber. I saw a picture a while back. The whole crew, from captain down to the bombardier and everyone else, were all women.
Wow.
That was pretty neat.
That's
awesome.
cool.
I'm waiting for the day when we won't even comment on that,
Yeah, no kidding.
on an all-woman anything. It'll just be the norm.
Yeah.
20 years ago, I thought by now we would have forgotten about that kind of thing. Just would have been normal. Can't believe we're still doing it.
I've been on an all-woman Alvin dive. Those don't happen very often.
No.
Yeah, that's pretty rare too, isn't
I
it?
don't think we've had a space station operation yet with all women in there.
We've had an all-women spacewalk.
Yes, that was good.
And that was an extensive spacewalk, too. That was very cool.
So we have joining us in the science chat, Mark Legg, says he's writing a book on the tectonic evolution of the San Clemente fault zone. So that's exciting because we're basically at the San Clemente escarpment, southern end of it, on 40-mile bank. So Mark, anything you want us to convey to the public about this area?
Yeah.
Feel free.
Yeah, absolutely. Happy to have more geology input. Study the minerals, but in terms of all of the fault lines around and the tectonics and the structural geology, happy to have any interesting facts, or if you see something cool as we're exploring. It would have been cool to see what Mark thought about that fault line we crossed in another dive, if that looked interesting.
Crossed a couple of fault lines on our dives. Not always obvious on the seafloor, but what we do see is huge amounts of broken up rock.
Yeah.
And thinking about the forces that would take to break up all that rock into, dinner plate sized pieces
Yeah.
is incredible. Most of the places we visited, in fact, have been they must have been tectonically active.
Yeah.
There's so much jumbled up rock everywhere.
Yeah, and the phosphorites are a pretty strong concretion. That's a very compact rock. It's hard to break it.
So Mark writes that the San Clemente fault is actually the San Andreas of offshore California. So does that mean it's the same fault continuing into offshore? And that it was the main plate boundary transform fault in the Miocene. So when was the Miocene, Kira? Tell us.
The Miocene is about 5 million to 20 million years ago.
Okay. So a lot of the action out there is either old or gone on for a long time.
Mm-hmm. Yeah, that's true. It's funny how we always give a range of many millions of years. Was it in the late? Sometimes they say late or early. I think the phosphorite deposits themselves were formed in the late Miocene, in a few even seem like they could be part of the Pliocene, which was the next youngest.
But we did find a fossil whale a couple of days ago, or a fossil marine mammal. I wonder how old that would be. Do you have any clue?
Yeah, that would could be from the
Pretty
same
old.
era.
On Cortez Bank. So apparently the San Clemente Fault has a slip rate of 3 to 6 millimeters per year with lots of earthquakes. It doesn't sound like very much, but it adds up.
Yeah.
I don't actually know if that's a high number or a low number.
I don't really either.
It's worth telling people for those who watched yesterday, all the rock examination we were doing, picking up rocks, putting them back, holding them up and turning them around, that it seemed like there was 100% phosphorite, or do we not know about yesterday? It was the day before?
The day before, we had 100% phosphorite recovery. So we got all the rock types we were hoping for. And we're learning how to discern the types based on looking at a bunch of rocks on the seafloor, which I'm pretty excited about. And I'm sure yesterday's dive went similarly. We could still use a few more ferromanganese crusts on this expedition, so we might try with our remaining 2 dives to look in regions that and water depths that might be more likely to have ferromanganese crust precipitating on exposed rock surfaces.
So what tells you that we're more likely to find some ferromanganese here versus like phosphorite?
It has a lot to do with depth and a lot to do with previous discoveries. Ferromanganese crusts really like low sedimentation rates, so I think as we climb higher on these banks, we're seeing a lot of sediment on the rocks, and for oxide deposits to precipitate from seawater, they really need low sedimentation. And that's a good indicator. And I think the deeper environments provide that. It can also help to have a little bit more, typically the deeper water masses in this region will be more oxygenated. You can form crusts in and near the oxygen minimum zone. But of course, since they're an oxide deposit, if you've got oxygenated water, it's favorable to oxide formation.
The phosphorites are different, right? Because the phosphorus is more likely to be released in the OMZ.
Yeah, the phosphorates here are not currently forming. These are
Is that a siphonophore?
looks like a giant siphonophore. So the current OMZ is a little less relevant to the phosphorite deposits, although it probably hasn't changed in massive amounts in the past several million years. But certainly when phosphorites are forming, they like a really low oxygen environment for that chemical replacement of carbonates by phosphate.
I'm learning so much about geology from this.
Yeah, I know, it's fun. I feel like in the morning shift, we really jump into geology, and then in the afternoon, you get
It's all about the biology.
a lot more species identification from Greg and Paul.
Are we hoping to core at the base when we land?
Yes, yes, we are, if it's good sediment.
So we're going to evaluate possibly taking Niskin, land, and core?
That's a good point. Yep, we'd want the Niskin before we get to the bottom.
Okay.
But we need
Get a visual
I'm
first.
pretty sure we'll have sediment, but
yeah.
let's see.
Roger that.
Still have a few hundred meters. Go.
Yeah, we're about 200 meters off right now.
Guess we're coming down pretty close to our launch site.
Yep, fairly close. If just confirming that the main goal is sediment, and if we have sediment where we land, are you as concerned about hitting that first point?
No,
Okay.
really.
But we can back up if need be.
Just as long as we don't drift too far away from the slope.
Sure. I think we're in a good place. I'm going to put on.
And then talking about sedimentation rates, what do you think are key factors controlling this process for a particular area? Is it like currents, closeness to shore,
Productivity. and
productivity
currents.
above?
Yeah, oh, for sedimentation in
Mhm.
the ocean? Yeah, totally. It depends on, yeah, the productivity of the phytoplankton. A lot of sediments in the deep ocean are composed of the bodies and the skeletons of phytoplankton that are photosynthesizing at the surface and then sinking. And depending on what their bodies are made out of, those minerals can be preserved as sediment. And if you're really close inshore, you can also get terrigenous sediments coming down and depositing, coming from river outflows into the ocean. And so in this region, the sedimentation rates are high because the California coast is famously an upwelling region, has strong currents that invigorate a lot of productivity here, but we have good fisheries. It also makes for fairly high sedimentation rates.
I see.
So Mark Legg is writing in that 19 to 12 million years ago, this area was a very active volcanic region with a large number of supervolcanoes that are still apparent with circular crater structures
Very
at the
cool.
center.
Yeah, I feel like that's the right time range for the formation of San Juan Seamounts.
San Juan, yeah.
And some of those.
Maybe Rodriguez, I'm not sure.
Yeah, I
Few
don't
other
know where
big ones.
Rodriguez fits in this.
It's further north.
Yeah. As well as one of those outer sites, I think it was Northeast Bank was also part of that volcanic event.
Should be about 100 meters off. It's coming up in our sonar.
So we'll be a little deeper than we thought initially.
We're like 75 meters off bottom.
Fingers crossed we see some cool coral today. Who knows?
Yeah, hopefully you guys got some good coral samples yesterday there.
Yeah.
Loads of them.
Yeah, what were those coral types we picked up yesterday,
Yeah, some
Gabriel?
Paragorgia, Swiftia. I'm not sure if we picked up any heteropolypus. I wasn't paying attention the entire time. I don't think we did.
I don't know, that's for sure.
All right, I'll stop at 50. Roger that. Come down.
Yesterday we got a real treat too once we were on board cleaning up Herc and pulling off all of our samples. A mola sunfish came by and hung out by the boat for a while. That was a nice sunset treat. One of my favorite fish.
Now at 1080 meters, we can see our oxygen starting back up. A little bit higher than it was on
Oh, yeah.
couple at 700 or 800 meters. Not very high, but it's at about 4% saturation. I think it was down to 1 or 2.
Maybe we can see some cool species or density bands around that kind of.
All right, Kylie, go ahead and see if you can start to spin to about 090. Sounds good. Let me know if you're getting a tug, though. Seems okay. Roger that.
My son is frustrated that we don't have a public chat open. But he's asking why the oxygen gets higher as we go deeper, and that is because there's oxygenated near bottom currents that come from below. I think they come from equatorial region forward.
So that
there's some coming from the subpolar regions towards the equator.
right. So there's some Atlantic water coming in at the bottom. Is that true? Because the Pacific is the oldest water and the least oxygenated.
I am kind of stuck.
Underneath.
I'm getting pulled.
Well, it's probably circumpolar.
Is fed by